Question 11 is a questionnaire question. So Raoul is the manager of a restaurant. He wants to find out how often local people eat in a restaurant. Raoul is going to carry out a survey using a questionnaire. Design a suitable question for Raoul to use on his questionnaire. So you need to design a question. It has to have a time frame and it has to have response boxes that are not overlapping. So he wants to find out how often local people eat in a restaurant. So a good question to start with is, how often do you eat in a restaurant per month? And I'm going to say 0 to 2 times. 3 to 4 times. 5 or more times. The fact that I've written times there suggests a unit. I could have got away with that by writing how many times per month do you eat in a restaurant, in which case 0 to 2, 3 to 4, 5 plus would have been adequate. So it's a 2-mark question. You get 1 mark for a question with a time reference in, and the 2nd mark for non-overlapping boxes, and there has to be some reference to units. Part B is a stratified sampling question. So the two-way table shows information about the ages of customers in Raoul's restaurant one evening. Raoul carries out his survey using only these customers. He uses a sample of 50 of these customers stratified by gender and age. Calculate the number of males aged 17 to 30 in his sample. Males aged 17 to 30. So we're looking at 10 people out of his total, which was 127. And I want that proportion of his sample size, which is 50. So I do 10 over 175 times by 50, and that's going to end up giving you 4. So he needs 4 males, 17 to 30 in his sample. 2-mark question, 1 mark for showing the working out, 1 mark for getting the answer correct. The final part says Raoul's survey is biased. That means it's not fair, it's probably not representative. So give 2 possible reasons why it's biased. Now there's a few different reasons here. The easiest one to miss, in fact, is going to be the fact that he says here, Raoul carries out his survey using only, no, not that one, it's up here. The two-way table shows the ages of customers one evening, okay, one evening. So there are 3 reasons that this might be biased. You need to provide 2 reasons for the 2 marks. The first reason is going to be that it only looks at the evening, because they said that it's in an evening, so it only looks at the evening. What about the daytime customers? What about the morning customers? People looking for breakfast. Another possibility is the fact that he doesn't give an option for, in the representation of the data, he doesn't give an option for people who don't attend restaurants. So there's no 0 available. If you look at that, then there's no option for zeros here. And finally, you can have the fact that age and gender might not be representative. So they've given you clues in the previous question about what it could be. They've mentioned a time of day, they've specified ages, they've suggested that there isn't a chance of 0. These are all just possible reasons why it might be biased. It doesn't mean it's happening. Okay, it's different if it says give 2 reasons why it's biased, but they're saying it's possible. Okay, what are the possible reasons? So you get 2 marks, 1 for each of those if you've got 2. Question 12 is a histogram question. The table gives some information about the distances in miles that some men travel to work. Draw a histogram for the information in the table, and a histogram is all based on the area of one of your bars. So what's important when you're finding the area of something is the width and the height, and that's exactly what's important here. You've got your distance, which is in class widths. So I'm going to just go ahead and write my class widths in there. Actually, that's got a width of 5 because it goes from 0 to 5. That's got a width of 5 because it goes from 5 to 10. From 10 to 20, it's got a width of 10. 20 to 30, width of 10. 30 to 50, width of 20. And we've got the frequency, which is the equivalent of whatever the area is going to be. So all that's missing here is the height. But in a histogram, height is called frequency density. So let's calculate the frequency density for each of these groups. Now, frequency density, just as if you had a rectangle with an area of 15 and a width of 5, and you were being asked to find the height, it would be 5 times what is 15. So the calculation is actually 15 divided by 5, and the answer then is 3, because we know 3 times 5 is 15. So frequency density here, it's going to be 15 divided by 5, which is 3. 17 divided by 5, which is 3.4. 10 divided by 10, which is 1. 6 divided by 10, which is 0.6. And 2 divided by 20, which is 0.1. So that's given me all the different heights of my bars. So now I've got to actually design the scale myself. What's the highest one? 3.4. So I'm going to make it nice and rounded, and I'm going to say that my highest point is going to be 4. And if by coincidence there's enough room to have it as 1, 2, 3, 4. And I'm just going to label this up as frequency density. Now, the scale that I've chosen means that each one tiny square is worth 0.1. So I've made life really easy on myself with regards to drawing this histogram. So the first bar is going to be from 0 to 5, and it's going to have a height of 3. So 0 to 5, and it's going to have a height of 3. So that's going to be my bar. My next one is going to go from 5 to 10, and it's going to have a height of 3.4. So from 5 to 10, and it's going to go up to 3.1, 2, 3, 4. My next one goes from 10 to 20 and has a height of 1. 10 to 20, height of 1. My next one goes from 20 to 30 and has a height of 0.6. So it goes from 20 to 30, there's 0.5, there's 0.6. And my final one goes from 30 to 50 and has a height of 0.1. So from 30 to 50, and that there is 0.1, so it's tiny. So that's my histogram for question 12. Now with regards to how the marks are allocated, you get 3 marks for getting a fully correct histogram. You get 2 marks if you've got 4 of the blocks correct. You get 1 mark if you've got 3 of the blocks correct. You get 1 mark if you've got a correct key. We don't have to worry about that. We haven't used a key method. Or you get 1 mark if you've shown that you are aware that frequency divided by distance is going to give you, or frequency divided by width is going to give you your frequency density. The next question, the next part of this question is another histogram question, but it's really tricky. They've given you a new histogram below which shows information about the distances in miles some women travel to work. And there's your histogram. And then it said X women travelled between 10 and 20 miles to work. Find an expression in terms of X for the total number of women represented by the histogram. So we're looking at the total histogram, and they're just telling us that this part here, however many women are in this, it's going to be called X. Now, I have nothing to work with here. There are no heights, so I can't actually find the number of women involved. The only thing I have to cling to is the fact that this bar takes up 100 tiny squares. I know it's 100 because if it was broken like that, you'd see that there's 4 lots of the 25 in there. So that is 100 little squares. I'm going to base everything in comparison to that 100. So let's start with this first really tall one. The copy quality is really poor, but here I have one of my blocks. There's another block, there, and there. So in this bar, I actually have 25, 50, 75, 100, 125, 150, 175, 200. So that is worth 200. Now if X is 100, and that's 200, that means that this bar is going to be 2X. Because it's 2 times that. Let's look at the next bar. Here I've got 25, 50, 75, 100, 125. And then it doesn't quite cut it there, so that's 125. And then I've got rows of 5. So 125, 130, 135, 140. So in here there's 140 little squares. Now, considering X is 100, that means 140 is 1.4x, because it's 1.4 times that. So we've got 2x here, we've got 1.4x there, we've got an x there. Let's have a look here. There's not a full 25 here, but I'll do it in roots of 10. So there's 10 there, 20, 30, 40. So in that part there are 40 little squares. So compared to our original point of 100 means that is 0.4x. Then if I count the little squares here, it's just a flat row of 1. So it's going to be 5, 10, 15, 20. So there's 20 little squares in there, which is 0.2x. So I've got 2x, 1.4, x, x, 0.4x, 0.2x. Find an expression. So it's an expression, not an equation. There's no equal sign. Find an expression in terms of x for the total number of women represented by the histogram. Well, it's our 2x column plus our 1.4x column plus our x column plus our 0.4x column plus our 0.2x column. And that's it. That's your expression for the total amount. It's a 2-mark question. You would get 1 mark for manipulating the bars and talking about the area of the bars in comparison to 100. So there's 1 mark. And the second mark is for, I haven't finished this, it's not simplified. The second mark is for writing the expression 2x plus 1.4 plus x. So that's 2x, 3x, 4.85, 5x. So the final mark then is down here. It's your answer mark. Question 13 is a tricky probability question. Isabel plays a game against Eric. Isabel is twice as likely as Eric to win the game. The probability that the game is drawn is 0.9. Work out the probability that Eric wins the game. So I'm looking at the probability that Eric wins the game. Alright, let's break this down here. We are looking at winning for a start. We're looking at winning. And I know that Isabel and Eric are playing. Now, I have no number to assign to the probability of Eric winning or Isabel winning, but whatever the probability is, I'm going to call it X, of Eric winning, Isabel has twice that chance. So if Eric has X chance of winning, Isabel has 2X chance of winning. So that's the winning dealt with. The one piece of information I'm given is the fact that if they draw, it's a 0.1 probability. So the fact that they can either win or draw means in order to find a number to share amongst their winning probabilities, I need to find out what's left over from the whole. So that is all the possible outcomes. Take away the outcome that they've drawn, leaves me with 0.9 probability of someone winning. Now, with regards to the total probabilities of winning, Isabella's 2x, Eric's 1x. So together, there's 3 sort of parts that need to be considered. So this probability of 0.9 needs to be divided between those 3 parts, which gives you 0.3 probability, which is really 1 part, or as I've called it above, 1x. So the question wants to know what's the probability that Eric will win the game. So Eric has only got 1 part. So the probability of Eric winning is 0.3. I can write that there if I want. And that means the probability of Isabella winning is going to be 0.6. And that all works out really, because if Isabella wins, it's 0.6 probability. Eric, 0.3. Drawing, 0.1. So they're all the possible outcomes, and they all add up to 1. So I know I'm correct. The answer is 0.3, sorry. With regards to the mark scheme, you get 1 mark for showing an understanding of wanting to find the probability of a draw not happening, and then showing that you've got to split that 3 ways. And you get an answer mark for having 0.3 or equivalent, so you could have 30% or 3 over 10, 30 over 100, whatever you wanted. Part B has the potential to be quite tricky unless you are very familiar with the and or rules, which I've mentioned quite a lot in this paper. So Isabel and Eric play the game 3 times. Work out the probability that all 3 games are drawn. So let's think about what happens. There's 3 games. There's game 1, there's game 2, there's game 3. I want a draw in game 1, and I want them to draw in game 2, and I want them to draw in game 3. Now the probability of drawing is 0.1, and is times 0.1 and 0.1. When you've got 0.1 times 0.1 times 0.1, don't forget it is a calculator paper, but it's a tenth and a tenth and a tenth, which is going to be 0.001. So the answer is 0.001. It's a 2-mark question. One of the marks is for showing an understanding that they're going to need to be multiplied together, and then the answer mark is for getting the correct answer. Question C is, I think, a great question. It's really difficult and it's a real thinker. They want us to work out the probability that Eric wins at least one of the 3 games. Now you could set up a probability tree diagram with 3 sets of branches, 1 for each game, and the options on those diagrams would be Isabel win, draw, Eric win, Isabel win, draw, Eric, Isabel draw, Eric, Isabel draw, Eric. Okay, that's a lot of work. What I would much rather do, let me put a big dot on the page to stop it blurring. What I would much rather do is have a logical approach to this. Now I'm going to think back to the first part of this question when I had to decide on what the probability was of Eric winning. Now the probability of Eric winning I decided was 0.3. The probability of Isabella winning was 0.6 and the probability of them drawing is 0.1. So let me just state that information there first. So probability of Isabella winning is 0.6. Probability of Eric win is 0.3 and the probability of a draw is 0.1. Now I am interested in the probability that Eric wins at least one of the 3 games. So he wins at least one of the 3 games. That means I very specifically want to know, or do not want to know, however you want to look at it, at the probability of Isabel winning, and I'm not interested either in drawing. I want Eric to win, okay? I want Eric to win. So the probability of that not happening is 0.7. Now, how many games are they playing in which he's got a 0.7 chance of not winning? Well, he's playing 3. So that's going to be 1, because it's everything, take away the chance of him not winning times by the chance of him not winning times by the chance of him not winning. So we're going to end up with 1 take away 0.7 times 0.7 times 0.7, which is 0.343. So 1 take away that equals 0.657. And that's the easiest way I can think of answering that question. Otherwise you're going to have pages and pages of calculations. So he's got 3 chances of not winning, and I'm going to take them away from 1 because that's the chance of everything happening. You're either going to understand it or you don't. If you don't, please go and watch the Maths Watch video clips. With regards to how the marks are allocated, there's like 2 pages of mark scheme for this because there's so many different possibilities of answering it. But if you adopt this method, you get 1 mark for showing your understanding of the not winning and not winning and not winning. You get an answer mark for showing 1 takeaway, and then whatever you believe your probability to be, and then you get an answer mark for getting the final answer.